Hello there. If anybody has been following me on LinkedIn, I've kind of been, I'll say QQ for quantum. I've been very interested in quantum computing, and in fact, it is the subject of my new book. I'm going to be calling it Rebels of Uncertainty. Anyway, I wanted to talk a little bit about a couple of presentations I've given at recent DevOps days as Ignite talks. I wanted to expand this out to a little bit longer than Ignite talk. Should be less, somewhere more than 5 minutes, less than 10 minutes. So Quantum, your crystal ball for what's next. So the question is, if you could see the future, would you wait to prepare? So the idea is that every technological revolution looks slow until suddenly, snap, it happens overnight, right? And one of the things I wanted to point out during my research is that if you look at from, the T in GPT is called a transformer, right? So that was originally defined in a paper called Attention All You Need in 2017. And by 2022, we have ChatGPT. So 5 years is not a long time. And if you look at what people are saying about what they're calling sort of the supremacy, quantum supremacy, I hate that term. I hate AGI. I hate ASI. But as a marker, they're saying it would be a million qubit fault-tolerant quantum computer. And most predictions right now are about 5 years. So we're in what I would call the GPT-1 moment or time era right now, right? So like I said, the crystal ball, I mean, if you look at what IBM, Microsoft, Google, PsiQuantum, IonQ, they're all saying 5 years for this sort of this point of which, 1 million qubits and a fault tolerant machine, right? And if it was just one vendor saying this, I'd say, okay, it's just the vendor. But they're all pretty much on this race, and they're pretty serious about this race. I guess, the meta point of this presentation is this: quantum computing is not a joke. It's still baby steps. It's still infancy. The stuff that you can do it now is still sort of science fiction. But again, go back 5 years from ChatGPT when everybody was caught off. Most enterprises were caught off guard. Most CIOs were caught off guard. And imagine if you could go back and prepare, knowing what happened from GPT-1 to ChatGPT. So again, there's some interesting breakthroughs. In 2019, Google solves this what they call the impossible problem. Again, it was game. They fabricated a chip, so there was a lot of pushback. But what they did is they solved one of these hard problems, intractable problems they call them, and it was basically something that by estimation would take 10,000 years on a supercomputer, not just a classic computer, but a classic supercomputer. They did it in 200 seconds. Microsoft is just, if you follow Microsoft and what they're doing, NVIDIA is declaring that quantum computing, is at an inflection point is in 2025. IBM and many others are promising within 5 years that we'll have a fault-tolerant quantum computer. And so if we look at sort of just the transitions of technologies. The came out in 1947, Bell Labs, and look at that ugly thing, right? That was the original transistor. In 2016, IBM created the first sort of commercial quantum they call the chandelier. I mean, so again, we're still a little ways from being able to put these things in racks, but trust me, there are vendors working on building refrigerator racks in data centers. So we're in what we call the noisy intermediate scale quantum. You gotta love an era that actually apologizes for the era. Like I don't think I've seen this in my 45 years of technology. The mileage varies, but this is like a 200 to 300 qubit. I'll be doing a lot more on if you don't know what a qubit and superposition and entanglement and interference. Those are really key sort of componentry of how this thing works, and it is weird. It's definitely weird stuff. But you look at the kind of things that they're trying to solve in simulation, very small bursts of technology. But when you get to the fault tolerant, 1,000 plus, again, this prediction is a million qubits. You're talking about protein folding. You're talking about quantum chemistry, redefining not only weather, chemistry, material science, space exploration, and then optimization, right? And just to give you an example, this is kind of a problem that you really can't solve on it's sort of on a, truly solve on a classic computer, which is just basically simulating penicillin, right? It's about 45 atoms, 176 electrons. To solve this, a true simulation longer than the age of the universe. The 300 sort of qubit, it's sort of demo simulation in the NISQ, but in supremacy, again, what mileage knows, is it 5 years, is it 8 years, is it 10 years? But it could be something that could be computed in weeks. So we talk about the 2019 Google, the 10,000 years to 200 seconds problem. And you got this company called PsiQuantum. I think PsiQuantum could possibly be the next Google if all this comes to fruition, right? I mean, this is an old metal or ironworks outside of Chicago that they're basically building this massive data center for quantum computing. I mean, this is big stuff and big investments. Nvidia's all in. Nvidia's put, sort of valued at 7 billion. But Nvidia sees this world. Originally I thought maybe, okay, would Nvidia not be interested in quantum computing? So there's this idea of what they call QPUs, right? These would be quantum processing units. Nvidia sees a world where, and this is the world that, from my research, is you're always going to have classic computers. So you're going to have sort of QPUs surrounded by GPUs. So you sort of, to make it real simple, your ingress to a quantum algorithm might be a classic computer with CPUs and GPUs. Your egress of the patterns coming out of a quantum process might go to GPUs and CPUs. Like, for example, I might do a pattern match of some very complex time series analysis, and the output of that quantum algorithm would still be not really recognizable, but you could load that into, say, a neural network or an LLM, and then maybe query to understand the pattern, right? So NVIDIA knows this is a big game for them as well. And there's an interesting paper we've used quite a bit in DevOps to talk about sort of technological revolutions, and it's by Carletta Perez, right? It's called the Technical Revolutions in Financial Capital. And what she says is there's sort of an installation period and there's a deployment period, right? And it is the deployment period really when the financial capital shifts. So I'll give you some examples of this here. So if you think about the transistor, we said that happened in 1947, but it wasn't until people started putting televisions in their living rooms that the transistor just blew up. Now, the transistor is, like probably the most significant technology invention, in sort of modern history. Um, some are arguing that quantum computing might be at the equal of that, but we'll hold off on that for a second. And then the internet was around for quite a while before Mark Andreessen and those cats created a browser, right? So it was a simple browser that really took the internet to where. And here's the thing, right? Like there were a lot of geeks in government and academia that were using the internet, but when Bob and Jane and Sue could basically hit enter on a browser or this thing called a browser, that's when the internet took off, right? Same thing with a television. When the Robinsons could watch TV in their living room, the transition took off. And we see this with AI, right? In AI, my book Rebels of Reason on the history of AI, like it's around 100 years, right? Like, I mean, Babbage's analytical engine, right? Like, I mean, but, but, and even within, the sort of the last couple of decades, it's been, neural networks have been very powerful, at least from like the early 2010s, 2017 was the attention is all you can need paper. Um, but it was ChatGPT. It was a simple GUI, just like the simple web browser that like shifted financial capital. I say there's going to be a ChatGPT moment. I don't know what it's going to be. It's probably going to be in commoditizing optimization with algorithms that basically just couldn't be performed, at sort of real time. But that's just a far off prediction. But the point is, that's when quantum, you know. So the question then is, if you knew the crystal ball, if you knew that back in GPT one time, and you knew what was going to happen in 2022 and post 2022, now last couple of 3 years, 2025, Would you have done things differently? And so there is some risk. There's a clear glaring risk, and we'll talk about that. That's the cryptology of cryptographic vulnerabilities, and that's the sort of known one. But the other issues like competitive advantage, talent scarcity, talent pipelines, lost IP. What if, patents, disrupted business models? So let's walk through this. So the quantum readiness, right, is going to be hard, right? Like the AI is right now, all the money's going through AI. So like you've got this double threat, right? One is like even if I wanted to, dear CIO, put some money in this idea that you have the crystal ball and 5 years might produce these things that would have been nice to have talent, would have been nice to have some IP protection, all those kind of things. But quantum, the other thing is the sort of noise level on quantum not working well right now is valid. It's true, right? The noise is true. There's a lot of ridiculous hype, but there's a lot of money. So it's a little harder than the AI leap. So I'm asking you to take like sort of a double leap of faith, right? But cryptology, right? This is true. They have this idea of harvest now, decrypt later, and that is that the thing is right now, if in 5 years your data decrypt the data you have now will be dangerous to your organization in 5 years from now, you're already cooked. Because right now, a lot of adversaries doing this HNDL, which is they're harvesting now with the assumption that in 5 years from now or sometime in the future they'll be able to decrypt it, right? So there's a lot of work going on in sort of quantum proofing, and sort of how to create sort of quantum methods of encryption, and all that stuff is great, but sometimes it's grabbing too much of the noise because here's the real scary risk, which is the competitive disadvantage. You don't want to be late to this party. You probably were late to the AI party. And companies like Moderna, Comcast, JPMC. JPMC is doing some incredible stuff with optimization and basically cryptology, right? And Volkswagen, Exxon, they're already piloting quantum. They have quantum pipelines, and it's not just the encryption stuff. They're looking for the advantages and talent scarcity, right? You think it's hard to hire you after ChatGPT came out and we have this sort of generative AI revolution, how hard has it been to hire talent, right? Imagine what it's going to be like with quantum. Quantum's a much more complicated conversation. And the pay, and there's already crazy numbers here, like there's going to be 250,000 quantum jobs needed by 2030. Only a few global experts right now. University programs are not scaling fast enough, right? Message being trained now or pay 10x later. Build your quantum pipeline. Don't drop everything, but basically you should be thinking about this. This is the scarier one, right? Like IP protection. You don't want your competitor patentizing and optimization. I was talking to an airline the other day. The landing a plane, the variables involved with landing a plane between fuel, the economics, if it has to divert, all that is a very complicated algorithm, right? These are the kind of complex algorithms, the intractable problems that quantum theoretically will solve. And if you're in a business where optimization is king, I mean, the traveling salesman, UPS, basically does algorithms where not only is it the traveling salesman problem, but it's the routes that never make left turns, right? Because it's more efficient to make right turns, right? Um, you don't want to be locked out on patents in this thing because you got started way too late. That quantum thing's never going to happen. You want to be hiring a pipeline, creating a pipeline and talent, and not just in cryptology, but in understanding your business. You want to start putting quantum technology and people into your pipeline now. Don't want to be Kodak or Nokia, right? We've seen this movie before over and over and over. We're actually seeing it right now. Who knows what generative AI, the graveyard of generative AI. Um, AI dominates budgets right now, and quantum feels abstract and distant, but disruption is near. So as a CIO, right, don't bet the farm, right? I'm not saying go out, but I'm saying start thinking about a quantum program for disruption, for all the things like the talent shortage, disruption, for IP protection, Basically, create sort of some emerging groups within your organization, hedge with pilots, partnerships, training. Bring the quantum people in, bring IonQ, PSI Quantum, obviously IBM, Google, um, you know, um, Amazon has something called brackets. So right now you can actually be allocating Amazon if you already probably have an enterprise account with Amazon, you could be playing with bracket tomorrow. So what leaders should do, start an executive quantum literacy program, fund pilot projects like for optimiz not just security, but optimization and simulation. Simulation, the three biggies with quantum is security, of course, quantum proofing, quantum cryptology, but optimization and simulation, these are going to be equally as big. Partner with universities and quantum startups, get involved with. I'm talking the business, not just security and that high polluting stuff, right? Um, like the technologies may be invented in the lab, but revolutions are in the living room. So like there will be a ChatGPT moment in quantum. If like I said, if you had a crystal ball in the GPT-1 era, what would you have waited for ChatGPT? Moderna is crushing it. Do you want to be a Moderna or a Blockbuster?